This call is now being recorded.
Yeah. So yesterday we have discussed about the functions and what is the importance of functions, how the functions are being reused again and again, right? Yeah. So yesterday I've given homework for variable length arguments. Like we have seen different categories of arguments present inside the functions of Python. Like the first, if we deal with the default arguments or keyword arguments or the positional arguments, whatever, the required arguments, or positional arguments are also called as required arguments. So we have seen so many examples of that. So I've given homework for variable length arguments. So has anyone done that? Has anyone done the variable length arguments? No, right? Because yeah, it looks a little
No.
bit complex. Yeah,
Yes,
so
sir.
we'll discuss
Yeah,
that
I
today.
tried it, sir.
Yeah, that's good. See, listen, guys. See, whenever I give homework, try to do it. If the output, if you don't get it, also that's fine. But the attempt should be very, very much important. By giving an attempt, you'll definitely uh, like enhance your knowledge and all. That's fine. So we'll discuss the variable length arguments now. So I'm opening my Jupyter notebook.
Sir,
Yeah, please.
sir,
Yeah.
sir, palindrome function, sir. Can you explain once, sir?
Sure. After the class, like once we end the session and all, we'll discuss about the homeworks. Okay.
Okay, sir.
We'll come back. We'll come back to that. Okay. So I've taken like a number of cells here. So today we are going to first discuss about the variable length arguments in a function. Okay. So in the variable length arguments, why these are required? Some functions have no arguments, right? Sometimes we face functions with no arguments. The first function which we created has no arguments at all. That, like, we haven't created any parameters or we haven't created any arguments to the particular function. So we have just executed that function without any arguments. But others have multiple, like we have seen a comma b comma c d, whatever you like. But what happens if the dynamically the length is changing? Like if you want to include a list or something, there are times we have functions with arguments we don't know about beforehand. Like, no, yeah, that's what. See, we don't know what's how many elements are present inside that, how many variables we need to include to that function and all. We are not aware. At the time, we'll come across this variable length arguments, which are very useful, which will come in very handy when you don't know the length of the arguments and all. Okay, so now we can create function to accept any amount of arguments. That's the main point. So previously, the arguments which we have declared are fixed number of arguments, like 2 or 3 or no arguments at all. But what happens if you don't know the number of arguments you want for that function? Then this variable length arguments, will come in handy. Definitely will come in handy. So when you don't know the number of arguments and all, then we use this variable length arguments inside a function. So we'll just go with a basic example for now, and then I'll try to convert that into variable length arguments. Okay. So first we'll consider a function where we can get the minimum value of two numbers. That means two numbers in the sense we are going to use two arguments there. Okay. So let's start a function def, and we'll use minimum of, we'll use two variables. Like we assign the values to the variables and we need to identify the minimum value between those two variables, right? Okay, so if a is less than b, if the a value is less than b, then definitely a value is lesser than compared with b, right? We'll use else statement, return b. That's it. So we are returning, you understood, right, the importance of return statement and all. In order to store some value inside a variable, the function value, we need to return something. Like we, after calling the function and all, definitely it should return something in order to store something inside a variable, right? So now what I will do is I'll create a variable with the name lesson number. and I'll use the function. So 10 comma 20. So print lesser number. Sorry, I haven't given the right name of the function. I'll just copy it. Minimum is not defined. Okay, I need to execute this function first and then followed by this. Yeah, see, so out of 10 and 20, the lesser number is 10. So it has given us the right output. Okay, so what does this function do? It simply checks the first number whether it is smaller than the second number or not, and then it returns the output, like whatever it identifies that the lesser number and all, it gives us the output. So what if we have a list of numbers and we need to identify the lesser number out of all the list, right? Okay, let us start. Like we'll create a function again. Okay, I'll create a variable with the name nums, and yeah, so like I'll return nums initially to check whether a list is acceptable by the function or not. And now what I'll do is I'll execute this function, followed by I'll create a variable again, lesser num is equals to min of nums. So we'll use minimum, the word, because min is a keyword already present in Python. So that Python will not get confused. I mean that it gets overwritten definitely, but yeah. So still, it's always good to give a new names rather than whatever present in Python and all. Okay. So lesser number equal to minimum of nums. So I need to replace the nums with the list. 1, 2, 3, 4, 5. If I print lesser num, automatically see the function, the logic what you have written is the nums, whatever we are declaring it should return the nums value. So now whatever the list you are declaring it to this particular function, it returns that particular list. Okay, type error, misses one required position of argument. Okay, whatever we are given is right. Still B. Okay, I need to execute this, I guess. Yeah, so sorry, I haven't executed this function, that's why it is showing us that error. And yeah, so as we can clearly see, the return statement, the whatever it is returning is the nums. So nums is the parameter whatever we are giving it to the function, and the parameter is in the form of a list, right? So the parameter is in the form of a list, so the list is being sent into that function, and in the return statement the list is being generated. So that's why whenever I print out the statement, it is throwing us the list values. So now I need to identify which number is the least one, so out of all the list elements. So for that, I need to understand the logic. Like first I need to write a for loop, right? Definitely I need to write a for loop, and I need to compare the elements present in that particular list. Like first I'll take one element and then I'll compare with all the elements. If it is lesser, I'll store that number, and again I'll consider second element and I'll compare it with all the elements and the first number. If it is lesser, I'll compare it with the first number as well, and then I execute the statements. Likewise, you do it until and unless the length of the list is finished. Okay, yeah. So first I'll assign something. I'll assign a value to the result. So the result should be the lesser number. So I'll assign some result value, that is nums of 0. I'll be assigning, like we need to initialize something, right? So we need to initialize a value. With that initialized value, we'll check with the different elements. Like we'll check with other elements which number is lesser, and then we'll overwrite that result value. That's the main logic we have here. Okay. So now I'll use a for loop for number in nums. If again I'm writing that if num is less than result. So result has got the first number from the list, because the index what we have used for result is 0. So we'll get this one value, the 1 is stored in this result. So now after writing the for loop, it compares with other elements present in the list, and if any number is lesser than that, it replaces that result. Remember. So now as we can see, the entire list, is like 1 2 3 4 5, and 1 is very less. So obviously the conditional statement whatever you are giving here, if that doesn't get satisfied, the result whatever we have given in the first state, it remains the same. Okay, so I'm giving it here like if number is less than result, if the number is less than that, I'll try to overwrite it, result equals to number. Okay, I'll try to overwrite it completely. That means, see, understand it properly. So the numbers of 0, so the result value is 1 now. Okay, 1. Now I have written a for loop where it iterates over the sequence like 1 2 3 4 5. So it first considers one value, 1 is less than 1. No, it's not right? So it doesn't go into this logical block. So again, the 2 is less than 1. That's wrong again. 3 is less than 1, 4 is less than 1, and 5 is less than 1. It's wrong. So the result doesn't change because 1 is always less than each and every element present in the list. So if I return result, yeah, if I return result, automatically it has given us the lesser number is 1. So understand this properly. So when you want to dynamically arrange or write some logic in the Python or any other programming language, for example, this minimum value of a list and all. So if you have a sequence like the string or list, if you want to identify something inside that sequence now, then definitely you need to use a for loop, and you need to have a if condition over there. Okay, here our main motto is to bring down the minimum number from the list. Right, so if we want to bring down the minimum number from the list, first we need to have a initialized value. So that's why I have taken nums of 0, the 0th value, the one I have taken the initialized value, and then I have written the for loop. For loop what does is, in the nums 1 2 3 4 5, it assigns one by one element into this num, and it goes into this block. Whenever this condition is satisfied, it overrides the result one. So the values what we have given in the list, like 1 2 3 4 5, doesn't satisfy any condition. So that's why the initial state whatever we have given 1, is the minimum value present in that particular list, and we are returning that entire result. Okay, so this is one way where you can have a parameter, and into that parameter you can assign a list or string or any numerical value. That's up to you. So but this is not a good approach actually. So if you want to increase the variables, or you don't know how dynamically the variables will come and go, so at that time you can use a list, but this is not the right approach, because we already have the variable length arguments available in Python. So based upon the variable length arguments, now you declare each and every if it is a list, or if it is a logic or something, based upon the number of variable length arguments, then you declare it. Okay, how to define this variable length arguments now? Okay, let us see. This is a little bit complex, guys, but try to understand it properly. After posting the video in the YouTube, watch it like 3 or 4 times, because this is a little bit complex. Okay, now what I will do is, I'll use def keyword and then followed by minimum, again minimum, and now I don't want the list to be there. I want the arguments to be in the format of variable length. See, the declaration of list is good, but that's not a good approach. So you want to declare if you have a number of variables which you don't have the length and all, then definitely you need to go for variable length arguments. Remember, that's a good approach actually. Okay, if it contains a list, then you keep a star asterisk symbol and followed by some name, args. This is official name in Python, args, which deal with lists. Whenever you're calling a function, you can provide a list to it. Automatically it takes that list into picture, and it identifies the result, and it returns that result properly. Okay, I'll copy this entire result thing. I've copied this, yeah, and I have given degree of minimum of asterisk args, and then followed by this. But while calling a function, now we are not going to provide the parameter in the form of a list. Remember, since we have used variable length arguments, there is no need providing the argument in the form of a list. Okay, so how we are going to provide the argument? Okay, first again I'll take a variable and I'll use the function name and followed by args, whatever if you want to provide the arguments. Now simply use parenthesis, no need of the square brackets also, use parenthesis and use n number of arguments, like n number of elements, how many you require, na? You give it there. For example, yeah, I'll use 55, 77, 88, 2 comma 3 comma 4. So out of all the 6 elements, the minimum value, it can, the minimum value out of all the list items, it's 2, right? So now if I print the lesser number, same logic, I'm not changing any logic here. So I've used the list, I've done some logic here, and I'm using the same logic and I'm applying it to variable length arguments. Yeah, hold on, I just need to execute this. One moment, name nums is not defined. Okay, sorry. Result equals to nums of 0. Instead of nums of 0, we need to use args. Since we have changed the name, we need to use args over there. Yeah, that's fine. Yeah, see, so the minimum number is 2, so it has declared us. Yeah, again I'm telling you, like, you can use a list to define a variable length argument, like, but that's not a good approach. So we need to use the syntax asterisk and args command to define a variable length argument very clearly. Okay, yeah, you can use this also, that's fine. But if you want to use it in a pure Pythonic way and all, definitely you need to go with asterisk args, where you can define n number of elements. If you don't know the how many elements you need to give it to the function and all, at that time now this will be very useful. That's why these are called as variable length arguments. See, I can mention n number of arguments here, like again 88, 1, 0. See, it's up to me. See, the value is 0 now. So out of all this, the logic whatever you have given, it compares each and every element, and if any element is lesser than the previous element, it overrides the result value and automatically it shows us the result. Are we clear, guys, with the args statement? I hope everyone.
Yes, sir.
Yeah. So after this, no, after the args and all, no, this is a variable length arguments, fine. But what happens if you give a key value pair? If you want to give like n number of key value pairs, then what is the exact variable length argument syntax you need to use? Okay, for lists and all, or for tuples and all, you can use asterisk args. But coming to key value pairs, no, definitely you need to use two asterisk symbols. Two asterisk symbols. Okay, I'll show you one practical example so that you guys will understand it perfectly. Okay, so I'll use def. I'll use uh, mini key, some function name. I've given it here, and here I'll give two asterisk symbols now. If you want to give a number of key value pairs, then you need to use two asterisk symbols. If you want to give only list or tuple items, then you need to give only one asterisk symbol. Remember that. After two asterisk symbols, you can give whatever name you want. But officially, Python has this name, quarks. So I'm using that quarks, but you can give any name you want. You can give any name. Okay, so I'll print out the quarks initially and then we'll see what happens. Okay, I'll execute this function. I'll take a new cell, and here yeah, so here we'll have the function name. Yeah, obviously you need to call the function name, right? So we'll store that inside a variable, key value. I'm storing that inside a variable, and how many key value pairs you want, you can declare it in the form of a variable, in the form of variables here actually. For example, a is equals to man1, comma b is equals to, in the form of variable declarations and all. Now whatever you use for variable declarations, directly you can give that syntax while dealing with key value pairs in variable length arguments. Okay, so now I'll print the key value. Let us see what happens. See, see key value, no? No need to print also. Like if you can, like the print statement, whatever the key value has given is showing as none. But yeah, the key value, whatever you have mentioned initially, a equal to man one and b equal to man two, will get converted into a dictionary. Already we have discussed about dictionaries in Python. So if you want to use variable length arguments per list, you need to use only one asterisk symbol. If you want a key value pairs to be associated with into that function, then definitely you need to use two asterisk symbols followed by a name. You give the name whatever you like. Okay. So your homework for today is like, yeah, do something about the args and quarks, like use a list inside a function and use dictionaries inside a function. A basic example, try to understand how the list and the key value pairs are working inside a function in variable length arguments. Okay, that's your homework for today.
Sir, after many key we use the parenthesis, sir.
Where
But dictionary we use a brackets, flower brackets, sir.
Yeah, so for dictionaries we use flower brackets, but see, whenever you're dealing with functions now, so this is the syntax. Like I told you like how the syntax is done in Python. First you define a def keyword followed by function name followed by parenthesis. So the inside the parenthesis now you give out the arguments or the parameters, whatever. Like if you want to give variable length parameters or variable length arguments or keyword or default or positional arguments now, you give it inside that parenthesis. So while calling the function also, you need to use the parenthesis only. So when you use quarks, automatically it converts the entire variables into this dictionary key value pairs. Yeah. So you use dictionary, but what happens if you print dictionary? If you want to print dictionary like 100 times, like different dictionaries, or like the same dictionary, you write the print statement 100 times, right? So instead of writing that print statement 100 times, you use the function statement there, use the for loop or something, and perform it. Like I've given the importance of for loop, if you remember, right? So in the same way, if you want to use the code again and again, you write the code inside a function if the code is repeating and all, and use that function repeatedly. That would be very easy for us, right? Yeah, are we clear?
Sir, here we can use the nested list also.
Yeah, it's up to us. You can use nested list also, but if you are using args now, you go with normal list and all. If you want nested list now, then create some arguments to it and you can use it. It's up to you. I'm just showing you an example of variable length arguments. It's up to you how to use the arguments in a proper way according to the requirement. Clear?
Okay, sir.
Yeah. So we have seen the functional statements and all, right? So multiple assignments. So assignments can be done in Python very easily. Like, so what do you mean by this multiple assignments? See, if I want to assign three variables like A, B, and C, and all has got the same value, then you write the code like this, right? A equal to 1, B equal to 1, and C is equals to 1. Instead of that, now we can use directly multiple assignments here. Like A is equals to B is equals to C is equals to 1. So if I want to print A comma B comma C, see the output. See the answer is 111. So you can assign multiple assignments very easily. Like you can do the multiple assignments very easily in Python by simply writing equal to in front of all the variables. So multiple assignments are very easy in Python for declaring them. Yeah, so we are good with functions, and yeah, we have always seen many lists. Like we have created a list inside a list, and we have seen so many examples of it. So you can create like you can create a empty list first and then use different lists into it. Like you can append multiple lists also. It's up to you. You can append any data type or you can include any data type into that list. Okay. Yeah. So modules. So coming to modules, we have seen methods of string, lists, tuples, and dictionaries. If you remember, methods like length, minimum, maximum, sum, and all, right? So already those are like predefined methods which are already declared in Python. So we are using those methods and we are defining them inside our Jupyter notebook. Right. So what happens if they are external libraries? So the packages, whatever the methods, whatever we're using are inbuilt actually. What happens if they're external? How to import them in Python? You know, so while dealing with data science and all, NumPy is very important. NumPy module. So NumPy is see the data types you have learned, like the strings, lists, and all. It has got some methods and all. In the same way, NumPy is another module which has got different methods in it actually. So NumPy is very famous. So if you want to learn data science and all, no, definitely the first thing where you come across this is that you come across something is the NumPy. So NumPy module. So NumPy is external package. It's not inbuilt actually. So we need to include that external library into our Python, and then we can use the methods, whatever the methods present in NumPy and all, now we can use. So today we'll try to understand how the external modules are being used in Python, how they are imported in Python environment, and how the methods of that external library are being used. We'll check that. Okay, yeah. So NumPy is extremely popular in Python module. Yeah, I told you, like when you're learning data science and all, NumPy is very, very, very much important. So installations can be done using pip. Okay, so if you want to install the external libraries, we have a separate keyword called pip. So everyone, I mean, few people were asking me what is the use of Anaconda prompt, since we have Anaconda Navigator and we have Anaconda prompt installed in our systems, right? So why Anaconda prompt? Why Anaconda? Everyone were asking me. So the use of Anaconda prompt is we can install a package or we can uninstall a package. Okay, since NumPy is not, if the NumPy is not available in our Python environment, then definitely we need to install the packages, install the NumPy module. So in order to install the NumPy module, we use Anaconda prompt. So after going into the Anaconda prompt, we use this pip command. So pip is a package management system. Okay, so it installs the packages and it uninstalls the packages as well. Okay, so pip is used to install or uninstall the packages, remember that. Okay, so think this as Anaconda prompt. Since I'm not using Windows, so I'm using Ubuntu, so my terminal will act as Anaconda prompt directly. Okay, for example, if I want to install NumPy, the first thing what I'll do is I'll go into Google and I'll type install NumPy. But since you have installed Anaconda and all, NumPy is already available in the Anaconda. No need to install it. But I'm showing you how to install NumPy. If there is no NumPy in your system and all, how to install it. See, install NumPy in Python. Okay, I'll click on the first site because this is the official site of NumPy. You can see clearly numpy.org install. I'll go here, and by using Anaconda you can install. See, there are like multiple ways to install a package. Like consider, like there are 3 ways to install a package. One is through Anaconda. Okay, through Anaconda you have the Conda is a package management software, again same like pip. Okay, Conda is a package management software, same like pip. Yeah, so you can use Conda and you can install Conda install NumPy. Automatically it installs the package of NumPy. Let us see if what happens if I type the command in my Anaconda prompt. See, it is collecting the metadata from the internet, and yeah, so it has collected the data and it is checking my environment whether it satisfies all the needs or not, and it asks me whether if you want to install the package or not. I'm typing yes. So it has installed package. Yeah, so and see the Conda preparing transactions, verifying transaction, executing transactions, everything is done, and the NumPy it's already available. If the NumPy module is not available, it will show us the NumPy package here. This is one way to install the external modules in Python. So the other way is through pip. So you can directly type pip install NumPy. You can clearly see the command here, pip install NumPy. Pip install NumPy. So I'll use pip install NumPy. I'll click on pip install now. See, requirement already satisfied. That means the NumPy module is already available in my system. So guys, please try this command like pip install NumPy and check whether the NumPy module is available in your system or not. If the NumPy module is available, then automatically it gives you this statement, requirement already satisfied. If the Numpy module is not present, it automatically installs the Numpy module in your Python environment. Clear? Yeah. So that's how you can install the packages or uninstall the packages also. Okay. If you want to uninstall the packages, simply type pip uninstall the package name. Okay. So Python is something where you have extensive library support. That means you have millions of packages out there in the market in Python library. So according to the project, you need to install those packages and then proceed with your requirement. Remember that. Okay. So the package installations can be done in three ways. Okay. I'm going to teach you in three ways. The first one is through pip. The second one is through Conda. The third one is through git bash. Okay. If you want to install something to Conda, so simply type numpy conda install. If you type something in the Google, or can you see this anaconda.org? If I open this link, it shows me the command to install numpy by using conda keyword. See, conda install -c anaconda numpy. If you to install this package with conda run. So this conda will work if you install anaconda channel in your system only. If you have not installed anaconda in your system and you are using a separate IDE or the channels, then you can install packages through pip. Remember that. Yeah, good. So three ways, git bash. So how many of you are aware of git? Can anyone tell me what is git and all? Have you come across this git or something like that? Yeah. So no one is responding. That means nobody knows about the git and all, right? So your next homework
No,
for
sir.
today is, yeah, your next homework for today is get a basic understanding about git. Get a basic understanding about git. Understand what does git do and how important is git in these days. Okay. Yeah. So Numpy module is something where it is same as list only compared to list. Now it is same. It acts same as list. But what is the basic difference between the list and the Numpy? Okay, it occupies less memory. The memory occupied by the list. Whenever you execute that, it stores in a memory management system, right? So something it gets stored in some memory. It allocates some memory to it. But when you create a list or create an array by using NumPy, it occupies very less memory compared to list. So if it is occupying less memory, it is very fast, right? It's very fast. So if it is occupying less memory, it's very fast. So you can access the elements very fastly. You can or like arrange mathematical operations or something like that very conveniently. So that's the second point here, convenient. So mathematical operations can be done very easily here. And the third point is very fast. It's very fast because the list occupies more memory compared to NumPy. So this is the architecture diagram of the list and the NumPy. How the memory is being saved. Suppose if it is a NumPy array, it directly goes into the memory in the form of bytes. But if it is a list, first it gets converted into pointers, and then the pointers are being converted into bits. There's a two-step process here. Two steps. Two-step process here while allocating the memory for the Python list. So that means it converts the entire thing into pointers, and then it converts that entire thing into bits. So it's a two-step process. Obviously, if it's the how many steps you increase, no, like the memory gets increased and the time consumption for the process is more. But here in NumPy, it automatically directly assigns in the form of bytes directly. Only one memory allocation directly. It doesn't convert anything there. So that's the main point. Where NumPy arrays occupy less memory and all. Okay, same like strings. Sorry guys. Hold on. Yeah, same like lists. Sorry. Yeah, same like lists or same like strings or tuples or dictionaries. It has got different methods and all. Right. So NumPy has also got different methods actually. Okay, so let us see like few basic methods how to create NumPy and all. Okay, remember So in order to import any external package, irrespective of the built-in packages and all, so we'll use a keyword called import. Import. So I'm importing Numpy module now because it's already installed in my system. I'm importing the Numpy module by using the keyword import Numpy. And if I want to create an array by using Numpy, I'll use the syntax Numpy dot array. So remember, like we have used to identify the minimum value, the list dot minimum value, the list dot maximum value. In the same way, I'll create an array by using Numpy module by declaring this kind of syntax Numpy dot array. So this is my method. So inside that method, if I want to display the numpy array and all, I'll just create a list inside that array. That means, so consider this array as a function, so this as a parameter. Okay, so this as a parameter. So you're providing a parameter to this particular function, and the end result would be whatever the return statement they have given there in the backend. That return statement will be executed and it shows us the output. Okay, if I print a, see, so it has executed an array again. See, it has executed an array by using the numpy module, and we have executed that array by using numpy.array method. Remember, like if you want to create a matrix. Now we have discussed about single dimensional arrays and all. But what if you want to create a matrix? So NumPy is very useful to create matrices also. So in order to create a matrix, simply use a list inside a list, many lists. We have discussed about many lists, right? In the same way, you use list inside a list. Automatically, it creates a matrix. See, you can clearly see that itself is a matrix here, right? So if hold on, guys, someone is shouting. Sorry. Okay, so we'll discuss about the methods present in NumPy now. So the first method is the D type. So it gives you the data type of that particular NumPy array. So let us consider, like if I type a dot d type, see, int 64. That means the values present inside that NumPy array are integers, and all the integers belongs to 64-bit. I mean, that's how the memory allocation is done, and it is showing us that particular data type. And if you want to know the size of the length, like size gives the length of the array. So if you want to know the size, if I type size, yeah, so the length of elements, like how many elements are present inside that particular array, we get that entire length. So you might be thinking, like we already have list now, then why NumPy has got these methods, like the length or the size to identify or to understand what data type is this and all. Yeah. So the developer, who has designed NumPy, again I'm telling you, the developer who has designed NumPy, now he makes sure that each and every function or method, the small thing also works, so he doesn't want to use another like the library or something to get the length of that something, right? So that's why, so from the minimum to the maximum number of functionalities, whatever that package can give, now he defines that entire thing into that package, and he launches it. So after launching it, now we consider that NumPy, the external library, we use it. Hold on. Yeah, sorry. Yeah, so that's how, we can declare our NumPy methods or functionalities accordingly. Okay, if okay, I have given so many the functionalities here in the PPT. So where did I get it? See, I'll simply go to the numpy.org. See, simply I'll type numpy in my Google. So every package, whatever you're studying or whatever you're going to install it, no, it has got its own official website. I'll go into this NumPy, and here I can see the documentation part here. I'll click on the documentation, and okay, they've changed the site. Let me see. Download documentation PDF version, historical versions of documentation, user guide. Okay, we'll go with the user guide. See what is NumPy installation, NumPy quick start. See the basics. So how to create an array and all. He's showing us. So each and every this thing, like the packages, the external packages or built-in packages, whatever it is, you know. So it has got its own official website. You go to that official website and you can read the documentation, how to install it or uninstall it, and you can have different methods present in that particular NumPy or any other packages, and you install that package and you do the methods. So whenever required, so you call those methods whenever you require the project requirement, according to the project and all, you call those methods and you do it. Yeah. That's how you import external packages by using import keyword in Python, right? So tomorrow we'll discuss more on this NumPy module and also a different packages as well. Like we'll discuss like 2 to 3 days now. We'll discuss more on the packages, like external packages and its methods. And I'll make sure that you get habituated to these methods and all, because in data science now you need to understand more about packages, not the syntax wise or something. So you need to understand like how the package is working, how many different methods are present in that particular package and all. Okay. Yeah, so I guess that's it for today. I'll stop
Sir,
recording the session. 1 minute, 1 minute. I'll stop recording the session.